you're going to use the entire chapter, and it has a lot of definitions. So let's go through some of them. First one, a polygon with 3 sides, this should already be in your notes, is called a triangle. Perfect. This is a definition that should be on your cheat sheet somewhere. You should know a triangle has 3 sides. If you know that without writing it down, that's fine. Don't put it on your cheat sheet. We name a triangle by its vertices and using the triangle symbol. So we would call this triangle ABC. I'm on page 2 right now. And then we have kind of 2 different types of classification. We can classify triangles by their side lengths and how many congruent sides they have, and by their angle measures and what their biggest angle is. Does anyone remember? No congruent sides. Go ahead.
Scale.
Yeah, scalene is how we say that. Scalene. That's a definition that you'll have to know on your test. Scalene, no congruent sides. That's exactly what I would put. Scalene, no congruent sides. Also, just something to keep in mind when you're writing your cheat sheet, don't write down like word for word what's in your notes unless you actually understand word for word what it's saying. Like, put it in your own words so you're not getting to the test and not understanding what you wrote down. I'd put it in your own words so you can understand it. Okay? That was on Monday. Also, just if you're a planner, this test number 4, is going to be not next Friday, but the Friday after, November 7th. Okay? So November 7th.
Not like next Friday, I mean this Friday?
Like, not in a few days, not in a week in a few days, but in 2 weeks in a few days.
November what?
7th. November 7th.
November 6th, 7th. Sorry, I need to be on.
Awesome. Okay. Next one, if we have 2 congruent sides, what do we call it?
Isosceles.
Very good. Isosceles is how you say that one. It's a weird spelling. Isosceles. 3 congruent sides?
Equilateral.
Equilateral. Perfect. You will just have to know those. Okay? We also classified, go ahead, Charlie.
Well, we have to like write out which triangles are like isosceles or equal.
Yeah, like it'll just say classify this triangle by sides and angles, and you would write isosceles, right triangle, for example.
And would we have to spell it right?
Or I'll give you a word bank, one of the 2. Or I will take some sort of misspell. Like, I really don't care. If I can tell that you're trying to say isosceles, that's fine. Like, if you put an I down, that's pretty good. Okay? We also classify it by angles. If we have all acute angles, for example, like 40, 60, 80, what do we call it? An acute triangle. Perfect. When you're classifying by angles, you are always looking at the biggest angle. That's how you're going to classify it, based off the biggest angle. If the biggest angle is acute, that means the rest are going to be acute, which we'll talk about later. So it's an acute triangle. If your biggest angle is obtuse, say this is like 100 and 60, 20, we call it an obtuse triangle. So our classification comes from the largest angle. Isaac, close your Chromebook for me. Thanks. If your largest angle is 90 degrees, if we have a right angle, say this is like 90, 45, 45, it's a right triangle. So again, we really only look at the biggest angle. In this one, if all the angles are the same, and in this case, they'll all be 60. What do we call that type of triangle? Equiangular is how you say that. What's up, Reagan?
I just noticed everything adds up to 180.
That is amazing. Everything does add up to 180, and that's one of the theorems that we'll talk about on the next page. So, on your test, you'll get something like this, and it'll just say, classify the triangle by sides and angles. Which one do you want to do? Doesn't matter. Middle one. Okay, let's handle the sides first. How many congruent sides do I have? 0. So how do I name it by its sides? Which one is 0 congruent sides? Scalene. Okay, scalene. Now, like Reagan said, which we don't technically know quite yet, but all of my angle measures add to 180. Does that mean this angle right here, is it going to be bigger than 90 or less than 90? It's going to be bigger. It's going to be obtuse. So if I classify my triangle by the biggest angle, how would I classify it? Obtuse. So this is an obtuse scalene triangle.
Does it matter which one?
We typically put the, no, it doesn't matter. If it's like a special name, like for isosceles, we typically put isosceles and then the angle measure. It doesn't really matter. I don't know. I usually put the sides first, but I put the angle first this time. It doesn't matter. And on your test, it'll just say by angles, and it'll have a blank. And that's where you would put obtuse. And it'll say by sides, and it'll have a blank. And that's where you would put scalene. So on your test, it really doesn't matter what order.
Will it tell you, like, if it's, like, the angle? Will it tell you if it's, like, scalene or not, or no?
Angles don't determine scalene. That's by your number of congruent sides.
Okay.
Okay. Any other questions? Okay, we also talked about, in this definition will come more into play later, but angles are opposite sides and sides are opposite angles. So if we look at angle A and we go directly across the triangle, what side is directly across angle A? BC. We would say that BC is opposite angle A. If we look at AC, here's AC, what angle is opposite of AC? B. What angle is opposite of angle C? Or what segment? AB. Perfect. So sometimes when we look at triangles like this, we'll call the sides kind of based on their opposite angle. Like we would call this side right here little a, because it's opposite angle A. This one we would call side B, because it's opposite angle B. And then side C, all lowercase. So we might see that notation as well. Questions on opposite? Okay, another definition. This should go on your cheat sheet. Interior and exterior angles. Interior angles are inside your triangle. So all of these orange ones right here are interior angles. Exterior angles are outside the triangle, and they form a linear pair with your interior angles. So this orange angle plus this purple angle add to what? If they form a linear pair. Yeah, 180. So for all of your angles, interior plus exterior is equal to 180. Okay. If you did not do this discovery activity on Schoology, I would do it because I can tell who did it, and you're not going to get your full notes points if you don't at least
I never would.
open it.
Brian's intruder.
Charlie, will you shut it?
No.
If it's not working, tell me and I'll show you. But again, I can view who has opened this link on Schoology and what you did in that link. If you did nothing, hey, I would focus. If you did nothing on Friday, you will get 0 points for these notes. What? So you have to open it.
That's berserk.
Crazy. Okay.
Open it right now.
No, after I'm done, yes. Next theorem. This one is probably the most important theorem of the entire unit. Triangle sum theorem. We're going to use it for the rest of the year. This should just come naturally after this unit. The sum of the interior angles of a triangle is 180. We're going to use that for the rest of the year. What this means is that the measure of angle A plus the measure of angle B plus the measure of angle C is 180 degrees. You add up all the angles, set them equal to 180. Because of that, if one of these angles is 90, say angle C is 90, and we set up the exact same equation, but we're plugging in 90 for angle C. If I just move this 90 over, measure of angle A plus measure of angle B is 90. So we kind of just use this theorem to also show that if you have a right triangle the sum of the measure of the two other angles is 90. Okay? This one, you don't really have to write on your cheat sheet because you can kind of use this triangle sum theorem to get there. This would save some steps and some algebra work, but you can technically use this theorem to get there. So if you have room, write it down. There's one specifically like this on your tests, but if you don't have room, no worries. This top theorem kind of handles it for you. Does that make sense? Okay. Real quick, let's do one of these examples. Which one looks the hardest?
1.
Okay, let's do number 1. You liar. It does not look the hardest.
What's
But
the hardest?
no, it does not. That's like the simplest numbers. But we can do number 1. Okay. All the angles in a triangle add to what? 180. So all I'm going to do is grab all of these angle measures and add them up and set them equal to 180. So x plus 4x is 5x. Will, are you doing something weird? Sketchy? Because I thought you were on your phone earlier.
The least sketchy. It doesn't have a move.
Whatever you have, put it away because I can't see it right now, so put it away.
Bro has it.
Okay. We're combining like terms with 5x, and I'm going to subtract my 20 over to get 160. And then I'm going to divide by 5. I get x is 32. So anytime you have all 3 angles in a triangle, add them together, set them equal to 180. Huh? This one is obtuse because which one of these angles feels like it would be the biggest? 4x or x? 4x. If I plugged this back in, that angle measure would end up being 128. So like Ryan said, this is an obtuse triangle. Questions on triangle sum theorem. There are 6 problems like this on your test. It's a good chunk of your test. It's the biggest portion of your test. Okay? Next theorem. This is also a portion of your test. I believe there's 2 or 3 questions on it. I would put it on your cheat sheet because this one, the questions that I give you on your test, the only way you'll know how to solve those questions is if you use this theorem. So if this theorem is not on your cheat sheet, you won't be able to do it. So put a star next to this. It has to go on there because there's going to be 2 questions that you literally cannot solve unless you have this theorem. This theorem says that the measure of the exterior angle, so that's angle 1 here, is equal to the sum of the measures of the 2 non-adjacent interior angles. So not this one, because that's adjacent to my orange angle. So we go all the way across the triangle, and our outside angle is equal to the 2 inside angles it's not touching. Okay? So the measure of angle 1 here is equal to measure of angle A plus measure of angle B. Questions on the theory? Yeah, go ahead.
So like if A was 80 degrees and then B was 40, like C would be 120?
Exactly, yes.
Boy.
So on your test, you're going to be given one like this, where you can't use triangle sum theorem because you don't have your 3rd interior angle. I would focus. So instead, we have to use our exterior angle theorem. Here's my exterior angle, 3x minus 15. And it is equal to the sum of my interior angles. What's one of my interior angles? X minus 6. And what's my other one? X plus 21. So I add those together, and I set them equal to my outside. Solve. Combine like terms on the right. I would get 2x plus 15. Subtract the 2x, add the 15. You get x is 30. Kind of speeding through this, but... And that's really it from Friday. What you need is the exterior angle theorem, triangle sum theorem, and these definitions, and your classifications. Questions about Friday. Okay, if you have not done your homework, do that today. Also, just a reminder, because this popped up the other day, I only take, listen, we're not done with the lesson either. We still have a whole other lesson. You guys said you wanted to go over 4.1 again. Okay. FYI, it's been like this all school year, but I'm going to really start cracking down. I'm not accepting any late work if it's after the chapter test.
I like that.
That means like unit 3 stuff, it's done. If it's a 0 in the grade book, it's a 0 in the grade book. Okay? So that also means you should stay on top of your things as they're coming up. You get more than enough time in class to work on it. Let's work on it in class, and you shouldn't ever have any homework. Okay? Okay. Today, we're talking about section 4.2. There'll be big ideas homework. This section is fairly simple, but it might take a second. Like some of the problems might take a second. Before we dive into it, let's do the warm-up. It says, write the equation of a line parallel to y equals 5x minus 3 and passing through this point. Parallel lines, how do their slopes compare? Same, different? Yeah, they have the same slope. So what's the slope of the y equals 5x minus 3? What's that slope? Remember, this is in slope-intercept form where m is our slope. So what's m right here? 5. So my slope is 5, and I keep the same slope, so the slope of my new line is also going to be 5. Here's something I would bet that you guys forgot in Algebra 1.
I remember everything.
Do we remember point-slope form?
Of course.
This?
Of
Y minus y1 is equal to m times x minus x1?
course, right?
Okay, we use this when we have a point, like this point right here, and we have a slope, like this slope, and we use it to write an equation of a line. So all we do is we take our point and plug it in for x1 and y1, and we take our slope and plug it in for m. So our y stays, that's going to be our variable in our slope-intercept form. y1 is negative 6, m is 5, x just stays as x, and x1 is negative 2. Once I solve this equation for y, I'm done. I have the equation that I want. So let's just fix a few things first. Y minus negative 6 is really the same as what? Y plus 6. Okay, I'm going to change that to a plus. X minus negative 2 can also be changed to a plus. And now I'm kind of ready to go. On the right-hand side, what should I do with this 5? Distribute. So y plus 6 is equal to 5x plus 10. Last step if I wanted to solve for y. What should I do? What should I do to the left? Subtract 6, I hope. So we get y is equal to 5x plus 4. Same slope because it's 5. And if we plugged this point in, we would get a true statement down here. Just kind of brushing up on our algebra skills a little bit. Questions on that one? Okay. I want everybody to put their pencils down. You're not going to be writing for 2 seconds. Okay. I have 2 squares in my hand. If I line them up, do we all see that these are the exact same size and shape square?
Yes.
Okay, 2 squares. Same size, same shape. If I just have 1 square, and I kind of move it over a little bit, this is the same square. That's called a translation. Do we remember that from Algebra 1? Translation, sliding left, right, up, down. Okay, I get the same square. If I take this square and I rotate it, do I get the same square? Yes. If I take this square and I flip it, I reflect it, do I get the same square? Yeah. What we're talking about today is the fact that these squares are the same. It gives us a lot of information about each square. So, now you can pick up your pencil.
same size.
Those squares are what we would call congruent polygons.
Yeah.
Congruent, Ryan and Robbie. Congruent polygons. That means they are the same size and shape.
They're a distraction by learning.
Focus up. Same size and shape. They are the exact same. Their measurements are the same. Okay? The way we get congruent polygons is if we do something called rigid motions or rigid transformations. And those are the things that I just talked about. Just do it. You got it. You got it. There we go. Okay.
What did Charlie just say?
Use your big voice right?
Okay, focus back up. So, we get congruent polygons from rigid motions. We take one square, we move it to the left, we get a congruent square. That's a translation. We take one square, we start rotating it, we get the same square back. That's a rotation. And we can reflect it, we can flip it, and get the same square back. So that's why we have congruent polygons, because we can take our shape and we can twist it, flip it, slide it over, and we get the same shape back. Okay? Also, for congruent polygons, all pairs of corresponding sides and all pairs of corresponding angles are congruent. You will have to know this. What that means is for each of my squares, for example, I need to find corresponding sides, meaning the top left of this square goes with the top left of this square, so they should have the same angle measure. Or like this segment on top goes with this segment on top, so they should have the same angle measure or side length. But sometimes you're not given the squares nice and pretty, and this one might be turned. I'd focus, and you might have to figure out which pieces are corresponding. So that's what we're going to talk about, is how to figure out all of your corresponding sides and angles. You have to figure out what matches from one square or one triangle to the next. So that's what we call corresponding parts. The pairs of sides and angles that have the same relative position in your two congruent shapes. Okay. And anytime you have congruent polygons, your corresponding parts are congruent. So you match your angles, you match your sides, and then you set them congruent to each other. Just a refresher, what does congruent mean? Yeah, we set their measures equal to each other. So a lot of stuff today we're going to be setting equal to each other. Okay? So let's look at this picture. There's going to be one nearly identical to this on your test. And I'm first just going to tell you, let's just match our letters. If I look at A here, A has one little arc next to the angle. What other angle from the other figure has one little arc? X. So I'm going to pair A and X together. For B, B has two arcs. What other angle has two arcs? Y. So I'm going to pair B and Y together. What about C? What does C go with? Z. So C and Z are going to go together. So what I did is I just said, okay, point A corresponds with point X. Point B corresponds with point Y. Point C corresponds with point Z. And since we have a triangle that is congruent to another triangle, because all the parts are congruent, here's what we write. This is called a congruence statement. You write your triangle. Let's call the one on the left A, B, C. Whatever we call the next triangle has to match with our corresponding parts. Meaning whatever letter goes with A, that has to be listed first, because it was listed first here. Whatever letter goes with B has to be listed second, and so on. So what should we call the triangle that it's congruent to? What should come first? X. Then what? Y, and then Z. So this little piece right here, this congruent statement, is all we need to write 6 different corresponding parts and how they are congruent. So, we look at this. Let's do angles first. We can see it from the picture, but we don't really need the picture anymore. Angle A corresponds to angle X, so they are congruent because the triangles are congruent. Angle B corresponds with angle Y, and they are congruent because the triangles are congruent. What's angle C congruent to? Z. Okay. So we have congruent triangles. That means we have 3 congruent angles. It also means we have 3 congruent sides. Let's look at side AB. I can look at the picture. AB has 2 hash marks. What other side on the other figure has 2 hash marks? XY. Okay. So I know that these two go together. The question is what order? If I listed AB first, what letter should come first? X or Y? X. Because X goes with A. So I have to write this as XY. If I wrote YX, my things would be flipped and my corresponding parts would not line up. So you have to make sure that every letter matches in all the places. They match up here, they match down here, and they match down here. Okay? If you see an A, you should always see an X in the same spot across that congruent symbol. So let's do it for AC. What would AC be congruent to? A goes with what? A goes with what letter? X. C goes with? Z. So it's congruent to X, Z. A is in the first spot. X is in the first spot. So A goes with X. C is in the last spot. Z is in the last spot. So C goes with Z. Last one is BC. Whoa. Last one for this example, my guy. These notes are long. This is like a 5-page of notes. No, but we're going to finish through page 8. Either way, it's my turn to talk, so shush. Hey! Wow, you guys have never listened that good.
Wait, is that strike 2 for Charlie?
You just ruined it, Ryan.
Is that strike 2?
Ryan, this is whoa.
Okay,
Ryan, make sure you get my cousin.
listen. Let's regroup. Hey, regroup. BC goes with what? What letter goes with B? Y. What letter goes with C? Z. Okay. So from this one congruent statement, we get 6 other statements. 3 about angles, 3 about sides. Do we all see that? Okay. The order matters. For example, we cannot say that triangle ABC is congruent to YZX. We cannot say that. That's not true. Because A doesn't correspond with Y. It corresponds with X, which I didn't even put down. Okay, but the order matters. In every single one of these, the order matters. Okay,
That felt real good.
let's do another one. Okay, it tells us that JKL is congruent to RST. So if I look at angle J, J is the first thing listed here. What else is the first thing listed on the other side? R. So J goes with R. So angle J is congruent to angle R. The next one, angle K, goodness. K is in the second spot. What angle is congruent to angle K? S. It's in the second spot. So the letter that's in the second spot. S. Stop with the random noises. It's distracting and it's not fair to those who actually want to learn.
Thank you.
Okay. Last one. Angle L. What does angle L go with? Angle T. Okay. So J and R go together. K and S. L and T. So we have these 3 congruent statements. So real quick, If angle R is 40 degrees, what's angle J? 40. They're the same. So this one's 40. Okay? Let's do sides now. If I look at JK, what side is JK congruent to?
It's JK. Oh shoot. TR.
What goes with J?
I don't know.
What goes with J? R, and S goes with K. So RS. All you're doing is looking at where J and K are and finding the two other letters that are in the same spot.
Yeah.
Okay. If we look at KL, KL's in the last two spots. So what would it be congruent to? S, I need two letters. ST are in the last spots of the other triangle. And then our last one, JL. JL is in the first and last spot. What's in the first and last spot of my other triangle? RT. Okay. The question, I mean, it's kind of formatted weird, but let's find TR, the length of TR. Do I see TR anywhere in here? No. Do I see something close?
Sure. Yeah.
What's close? RT. Are TR and RT the same thing?
Yes.
Whoa. Here's segment TR. Here's segment RT. Are they the same?
Yes.
Yeah, okay. So this is also congruent to TR. It's not from our congruent statement, but it's something else that we know from Unit 1. So if TR is congruent to RT, and RT is congruent to JL, and JL is 10, what's TR? 10. Good. 10.
Charlie, stop.
Yeah, don't push the desks. Okay. Questions so far?
Charlie, sure to get over.
I want you to try this one on your own. I will randomly be calling on people to explain their answer to the class. If you would like me to check your work before that happens, I will gladly do so. But I would do this because you're going to get randomly called on. I can check your work to ease anxiety, but I would do it. So, I'll give you a few seconds.
We're doing number 2.
You're doing number 2. I want you to write. Here's what I want. I want you to tell me which triangle is congruent to which triangle. I want you to tell me what angles are congruent. So angle J, K, and L. Tell me what they match with. And all of the segments. So I'm giving you half of your statements here. I want you to fill out the other half. Okay? This is only half. I want you to write the congruent statements for the other triangle, for RST.
What'd you say, Will?
Take a few minutes.
Well, you better read this to it.
Well, that's just the way it is. Suck it up. Robbie, what's your view? Huh?
I don't think anything's fine.
Jordan's snoring right now.
Jordan's snoring?
Yeah.
We'll leave him alone.
Hey, KL. It's like
You might want to wait for it.
Jordan.
Jordan. Jordan. Jordan.
Yeah, bucket.
Jordan.
There he goes. Good morning, bud. You gotta fill out your notes or you're not gonna get notes points. This is why I did this. Oh, so when you're done, if you want me to check, I will gladly check before you have to share in front of the class.
Oh, we gotta share it with everybody?
I said I'm randomly gonna call on people. I'll have 7 people I'm randomly calling on.
This is
And
good.
there's not many of
Hey,
you.
Rob.
There's only 12 of us.
You said what, Kevin? Huh? I didn't say anything. That's Ryan.
No, that was me.
No, that's Ryan. Ryan.
Don't talk to me.
Ryan, stop.
I hate you.
Whoa.
No, I hate you more.
I hate you more.
I hate you.
Oh, Neil. Oh, see me, amigo.
This is like that.
Be careful here, because this looks like angle J is congruent to angle R.
J is.
Can I have a little note, look at just your picture. Are angle J and angle R the same?
Oh, wait.
Yeah, so that. See what?
What are my benefits though?
I'll do it, I will do it.
No, you won't. You neglected me last time.
Cause you were being. Well, I would never neglect you.
Yeah.
Cause you're being.
Be careful, does angle J look like it goes with angle R?
Hey, Jordan, you.
It was J and T.
Huh?
Miss Cruz, I did it.
Excellent.
Yes, I did it actually.
Bad?
You were. Not bad.
Angle L with J.
You can hear it.
Bro, it's bored.
Try not to, don't use the little letters yet. We'll use them more.
Just a second.
Charlie.
Try to write it with the
What?
little segments so you can really see what's words.
Stop kicking my desk.
Hey,
I'm not doing it
other
other
than
than
that,
that. Everything right?
yes.
Wait, what are we doing?
You're doing number 2.
Kaden spoils my butter.
Does J look congruent to R? Based on your picture. Yeah, there you go. Yeah, R and L, yeah.
No.
Please?
All right, I think I checked most of yours. Angle J.
Likes you.
What does angle J go with?
T.
Angle T, okay. A lot of you put angle R. That doesn't quite make sense with your actual arcs. So, if angle J goes with angle T, I'm going to put T in my first spot. Angle K, what's angle K congruent to? S.
Oh, this is so easy.
So we put angle S and we put TS. What's angle L congruent to?
R.
R. So we put angle R and we put R.
Wait, you're with.
Hey, side conversations, not the time. Okay, now, Will, JK is congruent to what?
Yes.
Perfect, TS. Ryan, JL is congruent to?
RT. Wait.
Close, you're really close.
Slow down. Charlie shut.
Easy.
I'm
Hey,
encouraging
hey,
Oh, wait. JL,
JL,
and I was close.
you were close.
It's the other way around. Two.
TR.
TR, very good, TR. Hey, absolutely not. Last one,
See, I'm actually helping out my classmate.
KL. Go ahead.
RS, my bad. Wait, SR.
SR. Okay. Notice how the order matters. S should be in the same spot as S should be in the same spot as K everywhere. R should be in the same spot as L everywhere in all 7 things. Okay? Questions on those? There's going to be one like that on your test where you have to write all 7 things. Okay, next page.
Turn it over.
There's also going to be some like this on your test where you are told 2 things are congruent. Okay, hey, side conversations, random weird noises, the slurping, I'm over it. Stop it, knock it off. I should be able to teach without random noises every literally 0.5 seconds. Okay? Okay. We are told DEFG is congruent to SPQR. We have to find the variables. There's one like this on your homework. There's one like this on your exit ticket today. Okay? There's one like this on your test. I'd pay attention. Let's first, it says find X. Let me just find X in my picture. X is right here. It represents segment QR. Segment QR is congruent to what other segment? Careful with your order. QR, congruent to
FG.
FG. Technically GF is correct, but I want to keep it in the same order. FG. So that means my 2x minus 4, that's QR, is equal to, if we see congruence, we set it equal to, what's FG? 12.
Oh, shit.
So 2x minus 4 is equal to 12. And then we solve. 2x is equal to 16. If we add that 4 over, divide by 2, we get x is 8. There's going to be one like that on your test.
Oh my God.
We're going to do the same thing for y. Here's y. It deals with angle Q. What angle is angle Q congruent to?
68.
What angle? What letter?
Oh, F.
F. Angle F. They're both in the third spot in these initial congruent statements. So angle Q is 6y plus x. What's angle F? 68. So I set them equal to each other. We have two variables here. Can I solve this as it stands right now? With two variables and one equation?
Yeah.
No.
Wait, what?
No. We can't solve for this. Not a number, at least.
No.
But I know something about this. I know what x is. What's x?
8.
8. So I'm going to plug 8 in for x, and now I have something I can solve. 6y plus 8 is equal to 68. You'll have to do that on the test, where you'll have to use your previous answer, plug it back in to find your next variable. Isaac, can you wait till lesson's over? Okay. Now I'm just solving for y. What should I do first? Subtract 8. 6y is equal to 60.
And then divide by 6.
Divide by 6, we get y is equal to 10.
Yeah, this is too easy.
Good. All you're doing for this entire unit, or for this entire section, is matching your letters and then matching the numbers that go with those letters. Okay. However, we're going to start proofs a little bit. There will be one singular proof on your test, just an FYI, but we're kind of going to get started on them today. To do these proofs, we need to bring back some properties of congruence. Why are we talking? That is warning 1.
He's touching my chain.
Caden, hands to yourself. Ryan, stop yelling and maybe just turn around and say, Caden, please stop.
He doesn't listen.
Caden, listen, both warning. Warning 1 for both of you. If I hear it again, down you go. Okay. We have the same properties for triangle congruence that we had for segment congruence. Yeah, Charlie, absolutely not. Okay. So, triangle congruence is reflexive. I would put this on your cheat sheet. Reflexive. What does reflexive mean? If ABC is congruent to what? Do we remember?
CBA.
Not CBA. The exact same thing. ABC. Everything is congruent to itself. We also have the symmetric property. If ABC is congruent to DEF, does anyone know what happens?
DEF.
Yep, DEF is congruent to? No, ABC. This is the one that we flip. This one is everything is congruent to itself. It's the same on both sides. This one we flip. And then for transitive, hopefully we know transitive by now. What do we do for transitive? If ABC is congruent to DEF and DEF is congruent to JKL,
The JKLs.
JKL is equal to both.
And ABC is equal.
ABC is congruent to
JK.
JKL. We said we cut out the middleman. My middleman is DEF. So we cut out middleman.
ABC.
And we get triangle ABC congruent to triangle JKL. You have to keep these properties in mind because they'll show up in proofs a lot. Okay? On your cheat sheet, I think I'm going to have at least the names of these typed out, but you might have to write down what they actually mean. Okay?
Yeah, this is
Last theorem for the day. Third angles theorem. Okay. I'm going to kind of explain this one by example. Let's say that angle A here in this picture is 80 degrees. What would angle D be then? What's angle D if angle A is 80 degrees? 80. Okay? Let's say angle B is 40 degrees. What's angle E? 40 degrees. Okay. How would I find angle C?
40 plus 80.
40 plus 80, and we would subtract it from 180. What would angle C be? 60. How would I find angle F?
60.
How do you know it's 60? You're not
You're
wrong.
adding them together, then.
You add 40 plus 80, you subtract from 180. We did the exact same method to find angle C and angle F. And instead of having to do that actual math every time, we have a theorem that lets us skip all those steps. It says, it's called the third angles theorem. It says if two angles in one triangle are congruent to two angles in another triangle, in this case, angle A was congruent to angle D, and angle B was congruent to angle E, then we can skip over all the random math that we just did, and we can just say that the third angles are also congruent. So angle C is congruent to angle F. So we don't have to show it mathematically. If we have two congruent angles in a triangle, the third angles are also congruent. Okay? You'll have to use that in a proof eventually. Questions on that one, on that theorem?
We done?
No.
Very close.
I'll make it go longer if you keep asking me.
I've asked you once.
Okay. When you look at a picture, and you're going to be doing this a lot on your test and on your review, Isaac. When you look at a picture, there are some things that might be hard to see. I'm going to call them your hiddens, okay? When you're proving triangle congruence, here's things that could happen. One thing is your triangles might share a side. So you might have to literally write down this side is congruent to itself because that accounts for one of those 6 congruent statements I need for triangles. Okay? Triangles might also share an angle right here. You would have to say this angle is congruent to itself so you can show all 3 angles are congruent to all 3 angles. So anytime you have shared sides or angles, you're probably going to use the reflexive property. Vertical angles are also not going away. So those two are just vertical angles, and you will have to know that y'all have to know their relationship. What's their relationship between vertical angles? Vertical angles are
Parallel.
always,
Equal. Vertical. Angles.
it says it, if you just read the words on the poster.
Vertical angle.
Oh.
Read the words on the poster.
Vertical angle.
What does it say? Next to vertical angles. Always congruent. Thank you.
I said congruent like while I was
Congruent.
toes off.
Okay, so you should know that just off the top of your head. Hey, focus. That should just be an automatic thing. Vertical angles, they're congruent. Okay, we shouldn't have to look at the poster anymore. We should just know that vertical angles are congruent always. Okay. You also might have some parallel lines. If you have parallel lines, remember we have all of these angle relationships. So we have these 2 yellow ones that are congruent because they're corresponding. In this case, I'm looking at these lines being parallel or these lines. Okay. So we also have all these angle relationships that you can use with congruence. Corresponding, alternate exterior, alternate interior. Those are the 3. Questions on those? Just be careful. Some stuff is either shared or stuff that we already know that you'll just have to remember. Caden, leave him alone. Okay. We're going to do this example. First things first. Let's kind of match up some things. If angle A is 45 degrees, what's angle A congruent to?
B.
Angle B. So what's angle B?
45.
45 degrees. Okay. What we're looking for here is to find BDC. I'm going to want this entire angle, that entire red angle. Okay. If this angle right here is 30 degrees, what other angle is 30 degrees?
C.
Yeah, this little angle C. I wouldn't really call that angle C because that could be 3 different angles, but for now, angle C. So what we just did is we said measure of angle A equals measure of angle B. And measure of angle ADC is equal to measure of angle BCD. That's the bottom 2. Okay. Now, if I look just at the triangle on the right, triangle BCD, The only thing that I'm missing angle-wise is the angle that I need. From the other two angle measures, can I find this angle measure?
Yes.
How? You're right. I'm going to redraw this triangle. Here's B, D, C, and here's what I know. I know this is 30, I know this is 45, and this one's a big question mark.
Oh, that's equal.
Go ahead, Ryan. Oh, yeah, go ahead. Equal to?
180.
180, yes. Triangle sum theorem. It's your favorite theorem ever. We're going to add these three things up and set them equal to 180. So the measure of my unknown angle, BDC, my question mark, plus 30 plus 45 must be 180. Well, stop blowing it up. Just leave it at the size that it's at. Okay. If we solve this, we would get 75 over here. What's 180 minus 75?
110, 105.
105 degrees, because we're talking about angle measures. Also, just something to note, the side that these two triangles share is this one. So this was a shared side situation that just looks a little bit different. Okay? Questions on that example? Okay. We're going to do our very first geometric proof ever.
Oh my god.
This is not going to click right away. And that's okay. We're going to do a little bit every day, and by the time we get to the test, it'll start to make sense.
Are we gonna finish the package today?
No. Okay. Again, I would pay attention. If you don't pay attention today, it's going to get really confusing on Friday. Okay? We need to prove that these two triangles, the left one and the right one, are congruent. So what we need is all corresponding angles congruent and all corresponding sides congruent. We need 6 things. 3 angles congruent to 3 angles and 3 sides congruent to 3 sides. What we're going to do is first figure out what the picture actually shows us. So I'm going to just kind of set up my proof format with my statements and reasons. What's the first line of any proof? Given. Okay, so my given line is just what my picture tells me. If you look, you don't have a given statement over here. You're just given the picture. Okay? The picture tells me a few things. First, it tells me that AD is congruent to what? What other line has one hash mark? BC. Okay, pause for 1 second, because I want to put this in the right order to where it matches my triangle. So AD, should it go with BC or CB? CB. Just so I don't have to switch it around later to make it match. Okay. Let's do the other side that I know. I have this side DC here. What's DC congruent to? What's the other pink one? AB, but let's check the order. DC should go with DC. D's in the last spot. It's on your paper. D's in the last spot. What's in the last spot over here? B, A. Okay. That's all I know for my sides. So the last thing I need to show, what we're missing, what I need to somehow prove in my proof, is this side right here. I need to show that AC is congruent to CA. That's my last side pair. We'll come back to it in a second after we do the angles. But this is one thing that we're missing. And now let's check out the angles. Let's look at angle DAC. So this one. I'm naming it by 3 letters because I have a lot of stuff going on. Angle DAC is congruent to what other angle? You can just name it by 1 letter and I'll walk you through the rest. This angle has 1 hash mark. What other angle has 1 arc?
CB.
Angle C. And the way we would name it is C has to go in the middle with A. But then D goes with B and C goes with A. So we would get BCA. Does everyone see that? This is my pink angle, or my teal angle. Right here. Last thing I know is my other angle. This one and this one. So angle DCA is congruent to, what would it match with? What's my other angle? What goes with D? B. What goes with C? What goes with A? So BAC. And if you trace it out, BAC, that's my blue one. That's everything I know. We're not done with the proof. All we wrote down was stuff that was given to us. We have to show this segment is congruent to this segment, and we have to show the angle that we're missing. We have to show angle D is congruent to angle B. Once we show these 2 things, we then have our 6 congruent statements that would tell us that the triangles are congruent. Okay? So let's look at the angles first. We need a reasoning for angle D being congruent to angle B. Let's look back at some of our theorems here. Let's just start up at the top. There's not many theorems. Okay, would this be an exterior angle theorem? Are D or B on the outside of a triangle? Look at your paper. Are either of them on the outside? No. Would this be a triangle sum? Do we have measures for angles that we can add to? Are there numbers on your picture? Ryan, you're not even looking at your paper. There's no numbers. So we can't add anything. There's no numbers. And then this is all classification. So our very last theorem that we've gone over is this one, third angles theorem. Let's see if it works. It says if we have 2 congruent angles, congruent to 2 other angles, then that third angle is also congruent. So down here, do I have 2 angles on the left that are congruent to 2 angles on the right? Are 2 angles on the left congruent to 2 angles on the right? Yeah, we wrote that down. That's written right here. So therefore, since those 2 angles are congruent, the third ones also have to be congruent. And that's my D and B. So by the third angles theorem, those 2 angles are congruent. So I handled my angles. Check. I have to handle my side. So step 3, I'm going to just write this down, and we're going to have to explain why it works.
How many questions are going to be like this on the test?
Proof-wise, 1. Okay. AC is congruent to CA. What's another name for CA? AC. So what I'm really saying here is AC is congruent to AC. What property does that use? Reflexive. Good. So by the reflexive property, we get side AC is congruent to CA. It looks a little bit different than our usual reflexive, but that's just because we flipped these 2 letters around. Still works. So then our very last step is what we're actually proving. Angle A or triangle ACD is congruent to triangle CAB, and our reasoning is from up here. The definition of congruence tells us that if all pairs of corresponding sides and angles are congruent, then our polygons are congruent. So here we showed all pairs, all 3 angles and all 3 sides were congruent. So by the definition of congruence, our triangles are congruent. questions on that proof? We're going to do like a little bit every day and it'll start to make more sense. Okay. Let's do, hold on, practice problems first. We're going to do the evens together, and then you're going to show me that you know how to do the odds before you start your homework. Okay? So let's do the evens together. Let's start with number 2. Angle E. Here's angle E. We have 2 congruent triangles here. What letter does angle E go with?
B.
Angle B. What's the measure of angle B? 100. So what's the measure of angle E? 100.
Yep.
Okay. Let's do FE. Here's FE. What does FE go with? FE goes with, go ahead, Greta. AB. Yeah, right here. So what does FE equal?
3.
3. The pink ones are 3. Okay. Last one we'll do together is number 6, and then I want you to do the rest of them by yourself or with a partner before you do your homework. So, we have to find the measure of this angle right here. Do I know what the measure of this angle is?
Yes.
What is it? 46. Okay. Do I know the measure of this angle? Yeah, it's 90. Perpendicular lines make 2 90-degree angles. So what I have here is a triangle with 90, 46, and a question mark. What do I do?
136 minus 180.
Add them to 180. Yeah. So my measure of angle 1 plus 46 plus 90 is equal to 180. That's from the triangle sum theorem. You end up getting 44. Or, if you wanted to use technically the proper theorem, we would have used the corollary to the triangle sum theorem and said 1 plus 46 equals 90. Okay? Questions on any of those? Here's what I want. I want all Chromebooks closed until you show me number 1, number 3, and number 5, and that you can do them. Once you show me those, homework time. Yes. Okay, so work on number 1, 3, and 5, and once you are done, show me and we